Have you ever wondered how electrons fill in orbitals? Today, we're stepping into the intriguing realm of electrons and their orbits. These tiny particles aren't chaotic. They follow specific rules when occupying the orbits around an atom. Three key principles guide this process: the Aufbau Principle, Pauli's Exclusion Principle, and Hund's rule. They're like the traffic rules of the atomic world, ensuring order amidst all the atomic hustle and bustle. Just like people following traffic rules on a busy road, electrons too follow certain principles when filling up orbitals. First up, let's unravel the Aufbau Principle. Imagine a movie theater. People usually fill up the seats from the front row to the back, right? They don't randomly pick a seat in the last row while there are still available seats in the front. This is a simple everyday scenario that can help us grasp the concept of the Aufbau Principle in atomic structure. In the atom's world, the seats are energy orbitals, and the people are electrons. The Aufbau Principle states that electrons fill up the lower energy orbitals before moving on to the higher ones. Just like our moviegoers, electrons prefer to take the front row seats first, those being the lower energy orbitals. It's all about energy efficiency. By occupying the lower energy levels first, electrons maintain the atom's overall stability, so the Aufbau Principle ensures electrons take the front row seats first. Now on to Pauli's Exclusion Principle and Hund's rule. Let's start with the Pauli's Exclusion Principle. It's a bit like people's fingerprints. Just as every individual has unique fingerprints, no two electrons in an atom can have the same 4 quantum numbers. This principle ensures each electron in an atom has a unique identity, distinguishing one electron from another. Now imagine you're on a bus and there's plenty of seats available. Would you choose to sit next to someone, or would you rather have a seat all to yourself? Most of us would probably prefer to sit alone, right? Well, electrons are somewhat similar. This is where Hund's rule comes in. It states that every orbital in a subshell gets 1 electron before any gets a second. So, much like people on a bus prefer to sit alone before sharing seats, electrons prefer to occupy their own orbital before pairing up with another electron in the same orbital. This principle, combined with the Pauli's Exclusion Principle, guides the way electrons fill up the atomic orbitals and in turn influences the chemical behavior of atoms. So, electrons like to have their own space and identity, don't they? Let's now delve into the electronic configuration of atoms and orbital stability. Electronic configuration of atoms is not a random process, rather it follows a set pattern, guided by the Aufbau Principle, Pauli's Exclusion Principle, and Hund's rule. Each electron finds its home in a specific orbital, all in an attempt to create the most stable configuration possible. Imagine a seesaw. A seesaw is most stable when it's perfectly balanced, right? Similarly, orbitals prefer to be either completely filled or half-filled with electrons. A half-filled or completely filled orbital is like a balanced seesaw, providing maximum stability. Take carbon, for example. Its electronic configuration is 2-4. The second shell is half-filled, making it stable. This rule of thumb applies across the periodic table, so when you're studying electronic configurations, remember the seesaw analogy. Remember, balance brings stability, even in the world of electrons. Well, we've journeyed through the world of electrons and their traffic rules. We've discovered the Aufbau Principle, Pauli's Exclusion Principle, Hund's rule, and how these govern the way electrons fill up orbitals. We also delved into electronic configurations of atoms and why half-filled and completely filled orbitals are stable. Your thoughts, queries, or insights are most welcome in the comment section below. Thank you for joining us on this atomic adventure. If you enjoyed the video, give it a like, share it, and don't forget to subscribe to Facts Academy 0122 for more fascinating science content.